Today we're going to find the percent oxalate in our unknown compound. So what I have right here is the unknown compound that we dried and measured, all right, and it's nice blue crystals. And we're going to be measuring out, according to our directions, between 0.15 and 0.20 grams of our compound. And it says here we're going to use a boat. It's easy for us to tare the boat. So I'm going to make sure this is zeroed. I'm going to open the sides. I'm going to put my boat in there. My boat weighs something, so I'm going to zero the boat out. So it's like the boat magically disappeared. It's now no grams. And I'm going to open the sides and try to deposit approximately 0.15 to 0.20 grams in there. So let me see if I can do that carefully. All right, first of all, let me break this up a little bit. And let me try to get some nice crystals that are loose. All right, not quite. Why do I want small crystals? 0.152, that's pretty good. I'm going to put a little bit more. Okay, now I'm going to close the doors. Now why do I want some nice fine crystals? So that they'll dissolve easily. Because when I'm doing a titration, I need to dissolve my product, my material. And the mass here is 0.169 grams. So I'm going to write that down. All right, so now we're going to take this, and normally what we do is we save this for our next analysis, or if not, we're going to save it to recycle it. So we're going to use potassium permanganate, which is a purple solution made of purple crystals and water, and it kind of gets all over the place. It's in a dark bottle because it turns brown if it's left out and if it gets on your skin. And so basically you can wash it off and remove that with some peroxide. But the first thing I have to do after I filled my burette and the tip, notice there's no air bubbles.
Let me see.
Is get a reading. And this will be my initial reading. And I would say that the volume here is 2.30 milliliters. So I'm going to write that on my data sheet. Now you'll notice on the data sheet I also have the concentration of the potassium permanganate. And we found the concentration prior. We call that a standardization to find the exact concentration. And we have 4 significant digits in that. Now what I'm going to do is to quantitatively transfer my blue unknown to my container. So I'm going to try to coax this out first. And then make sure I remove all the blue that is in here. So I'm going to put a little bit of water and see if I can wash it through. Okay, just do another swipe here. And it seems like I can't see any blue anymore, so that's good. I'll add a little bit more water. Now, this material is soluble in water, but not fabulous. So what we have to do is heat it to 80 degrees. But before we do that, it says to put 20 milliliters of the sulfuric acid in here. So I'm going to take my sulfuric acid, and I'm going to measure out about 20 milliliters. If I get a little bit more, a little less, it's okay. And I'm going to add it. And now they want to make sure that we have about 50 milliliters of water in here. So you'll notice I have about 50 milliliters of water. And now what we're going to do is we're going to put it on the hot plate with our stirring bar. And I started to heat it up a little bit. And we're going to see that it reaches 80 degrees, just like we did for the synthesis. And I'm going to put on and this does best in the center, so I'm going to try to move it around. All right. So we're going to, the temperature right now is, well, 27. So we've got a ways to go. And then what we're going to do, we're going to titrate it with the potassium permanganate. Now our solution has reached about 80 degrees and I see no solid in there. And I have my stirrer going. You'll notice that the stirrer is quiet. That's because it's in the center of the, put these on the wrong fingers. Now what I'm going to do is add a little bit and see what happens. Can't believe it. There we go. So you notice we had a little color and now it's gone. So this reaction actually gets rid of the potassium permanganate and enables us to get a clear mixture. And the color disappears pretty quickly, so that means I can add it a little more quickly. Now it's taken a little longer. I think I should be a little bit careful. Notice that the tip of the burette is right inside the neck of the Erlenmeyer flask. So let's add some drops. Again, it took a few minutes to get rid of that. Let's add some slow drops. It's a little bit slower getting rid of it. Good titration requires patience. I'm going to lift this up just a little bit so I can see the tip. There's a tip hanging from, there's a little drop hanging from the tip, and I just want it to go in. And it should stay for a few seconds, and that looks pretty good. So, let's take that measurement and see what we get. I have to stand on this because I can't, it has to be at eye level. And my measurement says, it looks like 21.00. 2 decimal places. 21.00. So to find the actual volume of KMNO4 solution I used, I'm just going to subtract the final minus the initial. And so now we can do our calculations and find out the percent oxalate.